This assessment asks us to draw an energy diagram showing the 1,2 and 1,4 addition pathways to an alpha-beta unsaturated carbonyl. I have a generic version drawn on the board where the starting material splits into two pathways, one for the 1,2 addition product and one for the 1,4 addition product. The R groups here stand for alkyl groups, rest of the molecule, and I've labeled every molecule in order to save space on my energy diagram. We start by looking at the 1,2 addition pathway. They both start from the same place. The alpha-beta unsaturated carbonyl A reacts with a nucleophile B to form some kind of intermediate. For the 1,2 addition pathway, that would be the alkoxide intermediate C. That is going to get protonated by our H3O plus quench to form our product F, along with byproduct water. This is the 1,2 addition pathway. When we contrast that with the 1,4 addition pathway, again, we start at the same place. The alpha-beta unsaturated carbonyl A still reacts with a nucleophile, but reacting at the 4 position is a much slower reaction. And so we end up with intermediate D through a much higher activation energy. This enolate will still get quenched by our H3O plus quench E to form a more stable product G, along with our water byproduct. This is the 1,4 addition pathway. This energy diagram shows a difference between 1,2 and 1,4 addition. The 1,2 addition pathway is a faster pathway but forms a less stable product, whereas the 1,4 addition is a slower pathway but forms a more stable product. This energy diagram shows the difference between 1,2 and 1,4 addition to an alpha-beta unsaturated carbonyl.